Yeah, the main point of yesterday was, so, those who weren't here, Garrison, Samantha, was we were learning that we can now find the area under a curve approximately from creating rectangles, okay? And the rectangle formula, to find any rectangle, you do length times width, length times width, length times width, and you add up all the rectangles, okay? But there's two ways about going about it. You have to do a left endpoint rectangle and then a right endpoint rectangle, which are different. So we're going to go through this again, and hopefully you'll pick up on it very quickly. All right, so here we go. The formula for width, again, is b minus a divided by n rectangles, where b and a are, somebody help me out in this one, what would be the b and the a?
3 and 1.
Okay, so 3 is the b and a is the 1. So you do 3 minus 1 divided by n, which is your rectangles. They tell us we want 5 of them. Well, that would be 2/5. We're going to call it 0.4. So every one of my rectangles is going to be a width of 0.4, a width of 0.4. Okay, this is a left. I'm going to start at 1. Why am I starting at 1? Because that's the interval. I only want to go from 1 to 3. You with me? Okay, so starting at 1, I'm going to go to 0.4. Well, wouldn't 0.4 be like right about there, 1.4? The next width would be 0.4. Where would I land at? 1.8. The next 0.4 would go to 2.2. 2.2 plus 0.4 is 2.6. And then 2.6 plus 0.4, guess where I land at? 3. Okay, so now we have all the widths of the rectangle. Now we're going to draw them accurately. So to draw the left-hand rectangle, watch, again, you start at the 1, you go up to the graph, stop, go over to the next width, and then go down. And then you do that again from 1.4 now. You go up to the graph, stop at the curve, go over to the next width, and go down. Up to the graph, put a dot, over to the next width, down. Up to the graph, put a dot, over to the next width, down. It's okay. Up to the graph, over. This is an approximation of the area under the curve. Now, could we write a formula for all of these? Yes. Again, it's length times width, right? But don't they all have the same width? So the area for all of these would have a width of 0.4, and then I'm going to multiply by all the heights added together. Well, let's talk about those heights again, because this is where we were talking about. How do I find the height of this first rectangle? Well, wasn't it just 1 plugged in? F of 1? What about the height of this second rectangle? What was this height? F of what? 1.4? What about the next one? F of 1.8? What's this one? F of, and I'm running out of room. And then what's the last rectangle's height? F of, and then I could find the area very easily. Now, am I over approximating or under approximating right now? Over. I got way too many. But that's okay. The more you have, it gets better. But right now we're just testing that. We don't need to figure this out because we don't know what this curve is. We're just showing you a formula, okay? Next one. Let's do this one. Right endpoint of n equals 8 on the interval 1 through 4. So again, this is my b, this is my a. b minus a over 8 rectangles. 3a's, 0.375. Now, this is a right endpoint. So I'm going to show you how to do this on the calculator, because you need to start on the right. The right starts at 4. Would you agree? Okay. So I'm really, if I'm going left, though, I'm going from right to left, aren't I going to subtract 0.375? So what I usually do is I go 4, enter, and then I go minus 0.375, and then all I have to do is hit enter after that, and it'll tell me each of those numbers. So the first one is 3.625, which would be about here, 3.625. Then I hit minus 3.75 again, that's 3.25, which is here. then 2.875, which is about here, then 2.5, that's that there, and then 2.125, which is about here. I don't know what I just wrote, too many different decimals there. 1.75, 1.375, and then 1. Those are all the widths. Now this one's going to be weird to draw, but watch how we'll draw it, okay? Start on the right, go up to the graph, go over to the next width, come down, up to the graph, over to the next width, come down. Look, some are outside, some are inside because the way it's curving. Up to the graph, over, down, up to the graph, over, down at 2.5, and just keep going, and hopefully we've drawn 8 rectangles. Up to the graph. This one looks weird. That's my bad. It's looking bad, but you know, you get the point. But again, if I were writing a formula to find all of these, okay, my area formula for this would be the width of each one, which happens to be the same, 0.375, times the height of each one. So let's go over the height over here on the right. What's the height of this one? This was 4. What was the height of it then? F of 4. And then you'd add, we're not going to write all of them, then you would add F of 3.625. And then you'd add all the way, what would be the last height that I add? F of 1 or F of 1.375? You got it. Okay. This is your height. This one's your height all the way. These are the heights on the right side, the right height, but not that one. On the left, it's the left, the left, the left, the left, but not that one on the right. So that's how we can find area. And again, this is an approximation. Do you think this one would be an underestimation or an over approximation? What do you think? Under. Why? This one's over, but most of them. So that's why. Okay. Last final thing, turn over. What about if a table? And we're almost done. Okay, so the rate at which water is being pumped into a tank is given by the continuous and increasing function R of t. A table of selected values of R of t for the time interval 0 to 13 minutes is given. We're going to draw a graph just to show you, and then I'll show you how you could use a table, though. You don't really need to draw it, but the table is sufficient enough. But drawing it will help for those who need the visual. So again, on the bottom is always time. We're going from 0 to 13. I'm going to go from, I'm going to go up by 2s. Yeah, 2, 4, 6, 8, 10, 12, 14. That'll be easy. The y-axis is your R of t, your gallons per minute. And this goes from 7 to 27. I think I went by 3s. It worked in the other class. 3, 6, 9, 12, 15, 18, 21, 24, 27. It worked. All right, I want you to plot these points. So you're going to plot 0, 7, and then plot just 4, 13, and keep plotting. 6, 18, 10, 23, 13, 27. And you're going to connect those dots. So we are asked to do a right Riemann sums of 4 subintervals. So these are not going to be equal widths. So watch what happens here. You're going to go from 13, right here. You're going to go to your first point. You're going to go up to the graph, over to the next point, and down. That's your first area. Can someone tell me what the area of that rectangle would be? What by what? No, what's this? 3 width. What's the height? 27. So look, this was your width. From the right, that was your height. Yes? Okay. Let's do another one because we got to do 4 intervals. So now from 10, we go up to 10, go up to the point, go over, down, What's that area? What by what now? 4 by 23. Look, it's the width between here, the height right there. Okay? The next one, that's a smaller rectangle. What's that one? 2 by 18. And then this last one is a 4 by 13. You add them all up, multiply them together, you get 261. The question says, what does this represent? Well, remember, you are multiplying time, which is minutes, by the height, which is R of T, which is gallons per minute. What crosses off is minutes, and you're left with gallons. That's what that, exactly. Good old stuff. Is this approximation greater or less than the true? You should know greater, for sure. Now, let's put this all together. You ready? You ready for this? This is exciting stuff. Have you seen memes or Instagram reels that have that little symbol right there?
Yeah.
Okay.
Yes, I do.
We're about, she's like, yes, I do. Okay. Greater. Okay. This right here, what you're doing is something called the definite integral. Okay, let me explain what it is. You're going to write this down and we're almost done. This right here, this little sideways squiggle S, is known as an integral. It is the area under a curve. This is an integral. What you take an integral of, the function that you take, this right here is called the integrand. You just need to know it, integrand. Okay? Yep. What do you think the A and the B are?
Integrand. Oh, wait.
What's the A and the B? What's the interval, right? So this in mathematics would be the bottom one is known as the lower bound on the interval. So like if I was between 1 and 3, this would be the 1, okay? The B would be the upper bound. Okay, these are the words they use. You need to know them. The dx right here, yes, integrand. The dx is known as the variable of integration because, yes, in higher level mathematics, you can use a y. You can have an x here and a dy. You can do other variables that kind of make it a little different. Now, here's what's so cool. You ready for this? You ready to see this in live form? And then later on, we'll do it. So if I was taking this picture right here, I would take the integral to find this area right here. From what to what? What are my bounds?
1, 2, 3.
1 goes on the bottom, 3 goes on top. You put the function next to it. This is the x squared plus 1 function that we were doing from the beginning. You then write dx. Oh, wait. You go to your calculator. You hit the math button. You hit number 9. 1, 3, x squared plus 1. You have to tell it what variable you're using, which is x. The true area under the curve of what we were just finding on that front page is 10 2/3. Now, is there a lot more calculus that we just skipped? Oh, yes. Will we get to it? Oh, yes. You are now going to do a worksheet for practice. It says practice. This is part of your homework. This is what will be on the homework quizzes, okay? You can use your calculator for this. Don't do the one that has sign. We don't know how to do sign or whatever like that. The answer to this is in module 4. It says 3.1 rectangular approximation. You can click on that. All the answers are there. All the assignments are there, but you can work on this now. I would work on this before the quiz. It's probably better that you.
Is there homework? Yes. Do we want your rest program on there? No, I don't understand.
The March Madness?
No. So you go rest for not that.
Oh, wait, no, March Madness.
Oh, I didn't. No. Taylor had a similar from bracket me. If you put Florida, it's the first day of spring,
Sound waves.
Dairy Queen's giving out
If you put
free